All right, everybody, welcome back to the Summer of Protocols Protocol Town Hall, a periodic guest talk series focused on protocols and protocol research. In today's Researcher Salon, we will be talking with Lisa Neigut, or niftynei, about Bitcoin and the rise of the Lightning Network. There will be a link to the Summer of Protocols forum in the YouTube chat where we will host any of the conversation during this salon, in addition to the YouTube comments there. Um, our next town hall will be a guest talk on Wednesday, April 17th with Josh Stark from the Ethereum Foundation. You can find out more about the Summer of Protocols guest talk calendar, the protocol kit, and the upcoming Summer of Protocols 2024 program, as well as the call for applications at summerofprotocols.com. And so with that, I will hand it off to Venkat to introduce our guest today.
All right. Hey, Lisa.
Hey, everything.
All right. So, really excited for today's talk. Lisa and I have known each other for several years. During the pandemic, we actually were doing a podcast together called Scorpio Season. We're both Scorpios. This is kind of interesting for this program because normally we have this friendly sort of like tribal culture war going on between the Bitcoin and Ethereum ecosystems. But I think in the larger context of like protocol studies and developing this broad conversation that elevates all protocols, there's more in common and more to learn from each other than there is to argue about. So today we are going to be hearing about Lisa's day job, which I've actually never talked to you about much, Lisa. We've talked about all sorts of other things. But yeah, Lightning Network, which is for Ethereum people, kind of like a somewhat analogous to L2 type infrastructure. So we'll hear all about that, plus Lisa's own journey getting an improvement passed. So since the focus of this year's SOP is actually on protocol improvement. The applications are closing in a couple of days on Friday. So if you're putting in a protocol improvement grant proposal, please do so in the next couple of days. But this is the sort of thing we mean. There's a whole sort of like entrepreneurial process involved in like identifying the protocol that's interesting, identifying an improvement that's possible to do, and like working through the process to get it done. So we're going to see a live example of that today. So yeah, over to you, Lisa. Lightning.
Cool. Thanks, Venkat. Hey, everyone. I think you guys can see my slides. I'm just going to leave them like this so you can see what's coming. I think it's fine. Also, I feel like I need to apologize a little bit. I ran very behind on getting these out, so we'll see how this goes. So I'm going to start kind of with like a little bit of history. I'll give you a little bit of background about myself, and then I want to give, I think what I thought was really interesting digging in this talk is kind of a history of where the Lightning Network came from. I'm going to give a little bit of motivation of why it exists, walk through some of the timeline around like the rise of like how did we go from like an idea of like, hey, we need to scale Bitcoin to, okay, now there's like this whole spec process and governance and like all these different teams working and implementations. So trying to give some of the history there. All that kind of unfortunately happened before I joined, but that's fine. And then we'll get into like, okay, so I joined the Lightning Network at kind of an interesting time. What was my process like going through the saga of making a proposal, coding it up, getting other people to implement it, and then finally getting that more or less ratified. Cool. So let's go ahead and dig into this. I don't know how long this will take. I know we have an hour. If we have like too much time at the end, I can always go back and do like a more in-depth explanation of how Lightning actually works, because I kind of left that out of this talk. But yeah, so just a little bit about me. My name's niftynei, or Lisa. I go by niftynei on the internet. I am a block streamer. I worked on a project called Core Lightning, or still kind of contribute considerably less than I used to. Now officially a Lightning Spec author, contributor. And in the far ancient distance past, before I got into programming, I was an ISICer and then became a graduate of their Career Center in NYC. If you heard of that, technically I never graduated. These days, I do a lot of Bitcoin dev education stuff, and I also run Bitcoin conferences, which I'll talk about kind of at the end. Yeah, but let's talk about Lightning. So kind of the idea here is how do we go from this paper, The Lightning Network, Scalable Off-Chain Instant Payments by Joseph Poon and Thaddeus Dryja, to the Lightning Network kind of as it is today, with thousands of Bitcoin locked into basically what I say is the most distributed layer 2 protocol in existence, distributed in terms of number of participants that are actively running nodes on this network, and as well as like basically like there's no, it's very decentralized. Like there's no centralized nodes. Everyone who runs a node is an equal participant in it, and people have to basically bring their own Bitcoin to lock it into this protocol in their own channels, etc. I don't have like exact stats on how many thousands of channels there are on Bitcoin are locked up, etc. But I think last I checked, there's like 11,000 nodes on the network, and like tens of thousands of channels. And the total amount of Bitcoin in it is it's not really like easy to find out because it's sort of meant to be a private payments network. Yeah. Okay. So let's get into it. Like, what is the point? Why are we scaling Bitcoin? So, I mean, by this point, maybe this is something most people already know, but I'm just going to go over it from the beginning. So why did Bitcoin even need to add a payments network like this? Why didn't we just use the base layer? Kind of like, this is like old news at this point, but back kind of last decade, you have this idea, you have a block that's on the blockchain, and a new block in Bitcoin only comes every 10 minutes. This is built into the Bitcoin protocol. It's not something that we can change. Blocks are going to come every 10 minutes pretty much forever. I mean, you could change it hand wave, but it's basically like a known constant. The other thing about a block is the size of the blocks is relatively fixed. Let's say you can fit, just for the sake of argument, 1 to 4,000 transactions in the block. Well, if a new block comes every 10 minutes and you can only fit 1 to 4,000 transactions in every block, I think the math works out to about 7 transactions per second. I don't know, someone can check me on this. But basically the idea is like, okay, if we want Bitcoin to be this like global monetary unit, and we can only get 7 transactions done every second, that's not going to work for like global scaling things. So kind of started this journey of like, okay, how can we scale Bitcoin? And another thing about Bitcoin is if every block, a new block, basically makes a payment final. So it's like, okay, like I wanted to make a payment with Bitcoin, I have to wait until a block happens. That's fine and dandy when you're like making a wire, or it's not like a particularly time sensitive transaction. But for the case of like buying a cup of coffee, where you don't really want to be standing at the counter for 10 minutes waiting for the barista behind it to say, okay, yeah, I got your payment. 10 minutes doesn't really work for that. And you can't do like, you make it like you can only buy 7 coffees a second would kind of be one of the implications if we tried to make all of the transactions that people who own Bitcoin want to make. Doing it with like the layer 1 isn't going to work. So, and another thing I didn't put in here really is privacy. Maybe I should add that. But so kind of have these goals around, okay, we want to scale Bitcoin. We want to do it in a way where we can increase the throughput. So that's the number of transactions that can happen per second on the network. We want to make it faster. So I should call this really like speed to settlement. So the amount of time it takes for like a payment, like if I want to pay the barista or I want to pay, the coffee shop for coffee, how fast can I make like a final settlement? So how fast can I send them Bitcoin and there not be any question about me having sent them Bitcoin? Like it's over and it's in their account now. So, this is kind of like, again, these are goals of like the design system that we want to try and add to Bitcoin so we can achieve these. It needs to be non-custodial because basically we could send all the Bitcoin to a central like marketplace and then have them just settle all the trades on their own ledger using a database. But that wouldn't be non-custodial. That wouldn't be distributed. That wouldn't be, I guess, self-sovereign is the other word that Bitcoiners use. So, we can't really just use the centralized custodian to scale. We want it to be non-custodial, and we want it to be kind of sticking to those principles that are very important to Bitcoiners. We want a protocol that's decentralized, which means that there's no central person that you need to go talk to make Lightning payments happen. You and another person can still make peer-to-peer transactions happen between yourselves using Bitcoin and the Lightning Network. Cool. Okay. So, back then it wasn't called Lightning Network. It was like some sort of protocol. Okay, cool. So these were kind of the goals that you're aiming for with a protocol. So the kind of the idea that came out is like, okay, we're going to use payment channels. Maybe that's like a good thing we can do. And there's a couple of proposals that originally started out. we'll get into like the scaling Bitcoin thing in a second, because I think it's actually like a really interesting part of like the development of kind of like the scaling protocols in Bitcoin. But cool. So like I didn't really do a whole bunch of, so I apologize, I didn't do like some deep dives into exactly what these references are, but there's claims that Satoshi referenced at some point in his writings about the possibility of doing a payment channel. And maybe I'll talk a little bit about what a payment channel is here in a second. There's another early Bitcoin developer named Mike Hearn that had some proposals. These were probably like 2011, 2012, 2013 time range. First kind of, I would say, more like spec'd out proposal to make payment channels is from the guy named, I think, Jeremy Spillman on the mailing list, I believe in 2013. So that was kind of the first, I would say, almost like more formal proposal to do a payment channel. I should explain what that is. Like, I mean, I'll come back to it. Then there was Christian Decker, who later joined the Blockstream team effort, and one of his collaborators called Wattenhofer proposed something called duplex payment channels. These would let two parties basically send payments back and forth to each other. They had a problem in that if you established a payment channel, again, I haven't explained what that is yet, but if you established a payment channel between two peers, you'd be able to send payments between the two peers back and forth. But these had a problem that they had a problem. And the problem with them was that they had like a timeout. So like after a certain point in time, let's say like, I don't know, May 1st, 2024, you would have to close it down. So they kind of had this like expiration date to them. So that was kind of a problem. Like you could do payments with them, but they had like this sort of, the design had a flaw. And then finally, Poon Dryja, there's this proposal by Joseph Poon and Tadeusz Dryja that we now know and call the Lightning Network. But they had basically another payment channel proposal, which is also bidirectional, and it had the one of the really nice things about their proposal is that they didn't expire. So they could like kind of last forever once you set them up. They were good until they got closed at some point in the future. Now would be, so I'm going to put a little star next to that one because that is the one that we're actually going to talk about. And that is kind of the protocol proposal out of all the ones that were considered kind of at this time frame that all of the people kind of like rallied behind it and like, okay, this is the protocol. This is the scheme that we're going to use. How do we turn this into a actual working like network, etc. So that's kind of where that is. This is a screenshot of the first ever recorded presentation of them talking about it at SF BitDevs in February of 2015. So this is like, you know, the idea kind of first started, they first started talking about in February of 2015. There were then kind of this series of conferences that happened from 2015 to 2019 where they showed up and were talking about it. I think this is a screenshot from the Payment Channels Working Group at Scaling Bitcoin in Montreal, 2015. There was also a conversation about this Lightning Network payment channel proposal at Hong Kong, 2015. The paper itself didn't, like the final draft version of the Lightning Network paper didn't actually come out until like January 2016 is kind of when like the final draft came. So they had like a presentation in two different conferences that they went to where they were talking about the proposal before this draft really sort of solidified. And then in Milan of 2016, which about a year and a half, I guess, after the original proposal of the idea, etc., they had what was the first ever Lightning Protocol Summit in Milan after this conference. This is a write-up that Rusty did in October 2018. We'll introduce Rusty later. And he had kind of like this interesting, kind of just like an interesting summary. So on the 10th and 11th, following Bitcoin Scaling Milan, all of the people that were working on the Lightning Network produced a general outline for agreement on the protocol scope and specification. So over the past year, so basically 2015 to 2016, there's already kind of this thing called the Lightning community that's been working on exploring the problem space, writing implementations, creating Lightning channels to transactions on the test network. So this meeting is a culmination of these efforts across many companies within the Bitcoin ecosystem and finalizing invitations towards protocol compatibility and releases in the coming weeks and months. So I think this is kind of like an interesting thing of like, basically, there were a bunch of projects, et cetera. Again, I'll introduce a couple of those here in a second. So all kind of working on this idea, like there's this idea we're going to do lightning channels. Prior to this, there'd been a lot of other people already trying in independent efforts to make payment channels on Bitcoin work. And as of like Milan 2016, they kind of all come together. They sit down, and one of the biggest things that came out of this 2-day working group was the establishment of this GitHub repo called the Lightning Bolts, which is going to be the written specification of how these payment channel network, how the Lightning payment channel network is going to work for Bitcoin. So it's kind of like, all right, so someone comes up with the idea, they write up like draft of the paper, I think early 2015. They go to conferences, start talking to people about it. I think there might be some mailing list posts. I didn't quite dig into that. But then again, by like a year and a half later, all the different groups that have been working on payment channels kind of come together. They sit down and they produce the first draft of Lightning Bolts. And so this is going to be kind of the basis for coordination across all these efforts going forward. Cool. Okay. So that's kind of like a nice, neat history of Lightning Network stuff. I didn't really explain how payment channels work. I don't know how easy it is to switch over to another presentation. That's okay. I'll just keep going. And then at the end, maybe I'll wrap back to what is a payment channel. Cool. Okay. So there's like, this is kind of like a nice, neat history of like, okay, there are all these teams. I haven't introduced the teams, but there's all these different efforts working on trying to implement payment channels in Bitcoin. Someone comes up with this really great idea that kind of solves a lot of problems that the other prior proposals had. And that was the Poon Dryja channels. Everyone comes together in Milan, they sit down, they decide, hey, this is a protocol we're going to use. Let's start writing a specification for it. And then they start moving forward with like, okay, this is a specification. We actually have it written down. This is how it's going to work, etc. There's one small, it's like, okay, and then like Lightning move forward from there, etc. There's one small problem with all of this though. And that's that and this is from a write-up about that Milan summit. The problem is that the ability for them to ship the Lightning Network depended on a base layer change in Bitcoin in layer 1. And that ended up basically being like the segregated witness soft fork that went live in 2017. So I kind of I thought it was kind of interesting to go through, okay, so they want to do this payment channel network. They have a protocol, they have teams working on it. They've got like code basically is being written. A bunch of different people are writing code, kind of competing to make this thing happen. But they have this like blocker that they can't launch on mainnet until they got the soft fork in. And I don't know if any of you were paying attention to what was going on in Bitcoin in 2016. I definitely was not. But getting the soft fork in for segregated witness was actually quite contentious and wasn't like a given, if that makes sense. So I thought it was kind of interesting to sort of interleave like the SegWit stuff. I should probably talk about what SegWit is. I apologize, I don't have like a good like explanation of it in my presentation. The general idea for segregated witness is that it changes Bitcoin such that it changes the transaction format of how a transaction works, such that the data that you need to sign a transaction with move to like a different part of a Bitcoin transaction. This was important because prior to this change, you could make a transaction, a Bitcoin transaction, send it out to the network, have it get to the miner. The miner could maliciously, I don't know why they would do this, but they could tweak something in your signature data that would change the identifier for that transaction. And it won't invalidate the transaction. It's still a valid transaction. And then they could take that transaction that they had tweaked just slightly and include it in a block. And you would still get paid out all the money you're expecting to. Like your money would go where you're expecting it to. The money you were intending to spend would get spent as you wanted it, as you like intended it to. But one of the problems with this is that the identifier for that transaction would change. And this is a problem for Lightning for reasons we won't really get into. But the big problem is that in Lightning, you needed to be able to send a transaction out and know what the identifier for that transaction was, because that's important information for creating basically like another transaction that spends from that first one. And if any arbitrary person that sees your transaction, like a miner or maybe a malicious person on the network who just is like changing transaction IDs for fun, not that that exists, but it could. that could completely break basically the protocol for Lightning. So removing that ability for people to tweak signatures and change the identifier for a transaction was like a prerequisite. So that's kind of what they're referring to here. This thing of like someone being able to change your transaction is like the technical term for it is malleability. So in order to ship Lightning Network, we needed to fix Bitcoin transactions so that whenever you sent it out, you knew what the identifier for that transaction was going to be and that it wouldn't change. And Segwit was the soft fork that changed a lot of things in Bitcoin, but one of the important things that it really added was this stability to transaction identifiers, such that Lightning Network could actually function. I like to call Segwit like the Bitcoin omnibus bill because it changed kind of like pretty much every aspect of how Bitcoin works. It like sort of touched every part of the protocol. But for Lightning, the most important thing was this part of where they were taking the signature data and moving it to a different part of the transaction so that it no longer was an input basically to the transaction identifier. Fun fact, just because like, I don't know, I think it's interesting. Segwit is actually stands for segregated witness. And this is basically like fancy speak for moved the signature data. Because witness is sort of the fancy cryptographer term for signature, and segregated is like we moved it apart. We moved it somewhere else. Anyways, fun facts about why it's called Segwit. Yeah, cool. Okay, so that's Segwit. Just as like kind of an interesting timeline, because I thought as I was digging through into this history, I was like, oh, this is like new, interesting stuff. I didn't realize like kind of how clutch these scaling Bitcoin conferences were, I think, to like basically getting not only the Lightning Network project like out and moving, but also getting, I think, Segwit kind of like wrapped up and going. So here's like, again, kind of like a schedule of when all the conferences were. They started in Montreal in 2015. I don't know exact date. I want to say later in the year. This is the first ever commit for creating the proposal that would be Segwit. And it happened in December 2015. So it happened after the second kind of scaling Bitcoin conference. I have 2 copies of this. Okay, cool. Yeah, so that's kind of interesting. And then, yeah, so this second one was December 6th to 7th. The original post again for Segwit happened in December of 2020, like basically 3 weeks after the second ever scaling Bitcoin like academic conference. We had the first Segwit proposal, which is cool. And note that this was, again, like Lightning had started talking about early 2015. So by the end of 2015, all of a sudden we're like, okay, we have to get Segwit done if we want Lightning to happen. And here's like the first commit, let's go. What happened with Segwit? Well, the proposal like basically started in 2015. They worked on it. They had it basically out, shipped, and proposed by 15th of November, 2016. Notice that this was like 3 weeks after this Lightning Summit in Milan, where they come up with the draft for Lightning specs. Basically, 4 weeks, a month later, Segwit is shipped and it's waiting for miner activation. And then kind of like, while this is all like they ship Segwit, it goes out as like a proposal. It's not going to be activated unless all the miners say yes by a year later, the 15th of November, 2017. So this process kind of kicked off like an entire political process, which we're not really going to talk about today, of basically like this political campaign to go out and convince all of the Bitcoin pools and miners to signal for Segwit. And I think that's like an entirely different story. I think it's just kind of interesting how these things sort of line up with like when the Lightning specs were proposed and kind of like when these scaling conversations were happening. And you can kind of see the development and the proposals and like the shipping of code and proposals after people like come together and talk about it, and sort of like how things are getting coordinated. There's also mailing list posts that like show them kind of like planning and coordination and like how this like how they're going to get Segwit in, and then Lightning can kind of go after. It's like a thing. But yeah, I just thought it was cool. Okay. And then the Segwit proposal got basically ratified by all the miners, 100% of the miners, on the 9th of August, 2017. So a couple months before the deadline. So miners by that time, so it took almost a year for miners to do it. And so after this went live though, and after it's like, okay, SegWit's definitely happening, there started kind of this like race for mainnet. So all the Lightning implementations at this point, who in the past year have been working on writing code, building out their implementations, working around like having the spec that they're all implementing. Yeah. So once you have like a spec written, so once you have like the spec process written, right? Now we've got a couple of teams. They are going to go home and they're going to take this written specification and they're going to try and write it into code. So I kind of wanted to introduce like the 3 teams that were, there's been other teams along the way, but these are the 3 that have been involved, I would say, since the beginning and are still actively involved in the spec process today. Like, what is this, 2016, 8 years later? That's definitely the Lightning Labs team. They were founded by Taj and Poon, who are the original Lightning authors. These days, there's under like a little bit different management, but they've been working on Lightning since the beginning, like very, very beginning. And their implementation of Lightning is written in a programming language called Go. They're also kind of like the most United States-based team. So I think their headquarters are in like San Francisco. I mean, they're pretty global and like, well, pretty remote, I should say. But mainly like their leadership's mainly in the US. The other team that was working on it is Blockstream, who's a very kind of old school Bitcoin infrastructure team. They've been working on Bitcoin scaling projects since like, I don't know, 2013, 2014. And so they had a payment channel project that was going before the Lightning Summit in Milan. And this is Rusty Russell. He is very famous from the like Linux like networking process. And I would say he's probably kind of like the editor-in-chief of the spec process. He's the one who brought in a lot of the of his like knowledge of how spec processes work and open source software, and we're able to really kind of like grandfather the spec process for Lightning through like his work on, you know, early prototype of Lightning at Blockstream, and then being really involved in Milan and helping get the written specification out, kind of like how that process was going to work, etc. He also is like pretty famous in the past for having been a kernel maintainer and contributor for a long time, especially in the networking space. So I think like there's a long time Linux project called like IP tables that was his project. And is there anything else? He's done a lot of interesting stuff. So anyways, but he's like been in the open source software ecosystem for a long time. So he was able to bring in a lot of his expertise to what I think ended up becoming like the Lightning spec process, which is cool. Christian Decker is the guy. This is the guy who came up with the proposal for the payment channels, the Decker Wattenhoff, or I'll scroll back really fast. Decker Wattenhofer channels. So this one, Decker Wattenhofer, he's the Decker half of this duo. So he was like working on payment channels basically before all this happened, etc. And so their implementation was written in C. Rusty liked to joke it was to encourage other implementations in other languages, knowing that people wouldn't want to write and work in C. So that's the Blockstream team. And then there's also a team from France called Aslank. They started around the same time. And they were building their implementation in Scala. So kind of right at the bat, already at the beginning, we've got like 3 pretty like distinct, well-formed, well-defined teams that are all writing and working on payment channel scaling for Bitcoin in like basically the tooling of their choice. And they've all kind of come together again in Milan in 2016, and they're going to, you know, they draft up this writing of the specs, and from 2016 through 2017, all 3 teams are working on implementing what's actually written in the specs together. And then once you get this, and they're sort of waiting for SegWit to go live, right? Like they really can't launch this network on mainnet until SegWit is in and shipped on the main network. So that's kind of what they're working on, etc. Cool. So once that goes live, all of a sudden, it's kind of like this race to get the main network stuff up and running, see who can get their implementation out and making like the first Lightning Network payment over a payment channel on mainnet Bitcoin. But one of the important kind of processes that was also happening was trying to get interop between all 3 projects. So again, you've got 3 different projects. run by 3 different teams in 3 different parts of the world. There's a team in France, there's a team in US. I didn't say where the Blockstream team is. Rusty is in the land of Oz, which is Australia. Christian is hanging out in Europe, basically. So the Blockstream team is super international. So we've got like these 3 global teams that like, you know, all over the world trying to build Lightning Network stuff, etc. But it's really important if you have a common protocol that all of the separate implementations are able to talk to each other and follow the specification and do the right thing. So one of the kind of like small, I would say, processes that was happening in the background or happened kind of after this is they had this Lightning integration test. So they were working on getting Eclair, which is from the Islonk project, C Lightning, which is from the Blockstream team, and LND, which is from the Lightning Labs team. Christian Decker wrote this suite of integration tests that would run and check to see if all the different implementations were able to successfully complete tasks that the specification required, like opening a payment channel, closing a payment channel, sending a payment, that level of stuff between them. And they had the first, I thought this was kind of cool. This is from Reddit like 7 years ago. People are talking about when interop is going to happen. It's like LND and Core Lightning are passing 100% of the tests, and Eclair is working on some kinks. And this is Rusty, who's like, yes, they're covering the basics, but not the corner cases. We're close. Solid year of hard work by all 3 implementations. And the test went green for the first time in 2017 of November 15th. So about 2 months after 2 months after SegWit went live, the Lightning Network has 3 implementations that, at least for these basic tests that they say, are all kind of interoperating together. Looks like they added more tests at some point, and they didn't go all green again until November 2018, which is cool. Okay. Again, like, I don't know how much longer. Okay, cool. Right. So again, just like 2 months after it went live. And then in December of 2017, so about a month after all these interop tests are done, we have what I think is considered the first use of mainnet Lightning to pay like an actual thing, to pay for an actual thing on a service. So Bitrefill is the service that lets you, I think, like pay your bills or buy gift cards using crypto. So the idea is you can like use any kind of like, I don't know, crypto stuff, whatever, to pay your bills and interact with the real world with cryptocurrencies. They were one of the first, I guess they were the first to have a Lightning Network integration where you could actually pay your phone bill using Lightning. Alex Bosworth, who was working at Bitrefill at the time, was one of the first people to do it, which is cool. So he's got a little video from December 2017 where he's paying the first ever Lightning invoice to like just transact with Bitcoin through a payment channel, which is cool. And that was like, what are we, 2024 now? That was 7 years ago. These days, again, like, so the Lightning Network has grown since then. There's a couple more implementations. There's a couple more, there's one in Python now. I know I have a friend who is starting to work on one in a different language. So there's one in Rust now. So there's like a big Rust project, but that'll kind of happen later. And today we've got like, you know, thousands of Lightning nodes with thousands of Bitcoin locked up, and people can send payments to friends, etc., using Lightning. I paid a friend back for brunch on Sunday using Lightning, and it was cool. I just got to like click a button and scan a QR code and send them some Bitcoin over Lightning, and it worked really quickly. So it's come a long way in the last 7 years or so. Yeah, so it's kind of like the history of like how it started from a paper, and then we had a bunch of groups working on it, came together through a series of conferences, worked really closely with the people who were looking at expanding the block size through SegWit on the main chain. And then once they got SegWit in, sort of had to make sure that they were keeping their implementations such that they all interoperated. So anyone who wanted to join the Lightning Network basically has a choice of which implementation they want to use and run. And yeah, that's how you can participate in Lightning Network. Cool. So what I want to do now is I'm going to talk a little bit about the Bolt specification process. So what are the specs? Why do we have them? How do they get updated? And then hopefully we'll have a little bit of time. I can talk very quickly through my own kind of mini saga of getting a specification proposal from all the way from proposal to getting merged, which is exciting. Cool. Okay, so let's talk about these BOLT specifications. BOLT stands for Basis of Lightning Technology. So that's what BOLT is. It's pretty clever. Is it a backronym? Good question. I don't know. Cool. Okay, so why do we have specs? What's the point of them? So specification is supposed to be a technical description of how a Lightning node must act and behave. It is not meant as an educational document. And the goal is that another developer, so this is basically meant for technical audience, and they're supposed to be able to pick up this Lightning spec and implement a working Lightning node implementation. So like take the specification and only using the specification, they should be able to write code that if it follows the spec that they're reading, it should be a work. They should, at the end of that process, I don't know how long it'll take them, probably a year or two, I don't know. But at the end of it, they should have a working Lightning node that they should be able to point at any other Lightning node on the Lightning network that speaks the same specification and have it work more or less flawlessly, fingers crossed. And the point is you wouldn't need to go digging through other people's code to figure that out. So that's why we have a spec. Cool. Okay. I think it's kind of interesting to contrast this. So you're like, duh, okay, isn't that how every protocol works? Like that seems like the way that specs and protocols should be done. It helps with decentralization. So one thing that's kind of cool, I think, to notice about this Lightning process is that at the end of the day, like we ended up with a decentralized, both in terms of like the protocol itself and the technology is decentralized, but the number of teams and implementations that are working on the project is also well decentralized, both in terms of like, funding sources. Every team has money from different sources. Every team has a different language that they're implementing in. So you kind of end up with this nice redundancy across the ecosystem of people that really understand the protocol and have worked to implement it independently. So you also get this nice distribution of knowledge about how the protocol works across like disparate ecosystems, etc. Okay, so this is kind of like the goals of the Lightning bolts. One thing that I think is kind of interesting to contrast that to is kind of the specification. It's not even really a specification process. It's an improvement proposal system for Bitcoin, which is the BIPs. And so there's some really like BIPs are kind of like main chain. Here's how I want to change Bitcoin. Here's how we're going to do it. The SegWit process, the SegWit like proposal and change to Bitcoin is specified in a series of BIPs. There's kind of some big differences between like Bitcoin Core and Lightning, like the BIPs versus the bolts. So BIPs again stand for Bitcoin improvement. I think is it Bitcoin improvement proposals, something like that. Bitcoin improvement proposals. Okay. So their main chain, this is mostly stuff that has to deal with like wallets or transactions or upgrades to the main chain, etc. But it's all just like Bitcoin layer 1 stuff. The BIPs are not necessarily specifications. So like in the bolts, we have this requirement that a Lightning specification needs to be, the specification needs to be a technical document that someone else can read and from it implement like a working Lightning node. BIPs are kind of more just like descriptions of how new things will work. They give like a rationale, they give like history. Sometimes they'll have code in the actual BIP, but they're not necessarily the same as like a whole specification. And so kind of also a notable thing is like when Satoshi Nakamoto sat down and wrote Bitcoin, the first version, he didn't specify it. He didn't write a spec document. So the entirety of how Bitcoin works and how like what the consensus proposal and mechanism is for Bitcoin isn't specified anywhere. Instead, the specification, as it were, is Bitcoin Core. So how Bitcoin Core does things for Bitcoin is considered the specification of how Bitcoin should work. So there's like only one code base that has like kind of that knowledge in it. So that way it's like kind of centralized. And again, there's no written description of how it's supposed to work. So if someone wants to know how Bitcoin works, you have to be able to go and read the Bitcoin Core source code, etc. The bolts, I think, are kind of one way to think about them is a little bit reactionary to this process that existed, at the time that the bolts came out. So they're Lightning only. Again, they are technical specifications all the way through. The entirety of how Lightning works is considered to be specified or part of the specification. And each node should follow the spec. So it's kind of like the spec is the truth document for the network, and there is no canonical Lightning node implementation. If you want to know how Lightning works, you should, in theory, be able to go and read the specs. Cool. And then, so once you have the spec process, it's like, okay, you have the bolts. How do you update it? How do you change it? What's the process for getting a new proposal or like into the specifications? There's kind of like some communication channels that I'm going to go through on the left of the slide, and on the right side of the slide, I'm going to talk through how all of the kind of like the process of once you've like communicated what your changes, the actual process of what you're going to do. So usually the first thing is if you have something you want to change, you send it to the mailing list to get like comments and sort of almost like stake a claim that this is a thing you want to do and like make an official record of its existence in the ecosystem. So there's a mailing list post. I think the mailing list has changed recently. I've been a little out of the loop lately. You can also make a pull request. There's some issues to GitHub repo, but the mailing list is kind of like the canonical place for new proposals for how Lightning should work. There's also an IRC channel that's mostly defunct. Most stuff just happens on like the mailing list. And then we also have spec calls every 2 weeks. So generally you would like send it to the mailing list, then you would talk to the person who kind of runs the spec call, try and get it on the agenda for the upcoming spec call when you want to talk about it. And then during the spec call, you have basically a few minutes to explain what changes, talk about why it's important, maybe try and elicit feedback from the other people who work on the specs or have all the different implementations, etc. So that's kind of like an important thing. And then there's an in-person Lightning Summit, very similar to the Milan Summit, where we go through specification proposals, etc., the process. And those happen, I would say, every year, every 18 months on average. I think since Milan, there's been one in Adelaide. That was my first spec conference. So I got to go to the second ever spec summit. I think we had one in Zurich after that. And there was one in San Francisco. I don't know. I think there's been like maybe 4 or 5, which would make sense over the last like 8 years. Cool. Yeah, so that's the spec process kind of. There's mailing lists, there's like online calls or like video calls, and then there's in-person meetings, and the in-person meeting is invite only. You kind of have to have you either have to be working on an implementation that exists, writing your own, participated in the mailing list or coming to spec calls. Like you have to be involved in the project in some way in order to be invited to the summit. But it's supposed to be a pretty open process, right? Like we try as much as possible to do this like open source stuff. Like, there's mailing lists, the decisions are supposed to be public for the most part. I think the calls get recorded and there's recordings of the calls that get published. So if you can't make a call, you can go and look them up later. Cool. Right. And so then getting it ratified. So once you have a proposal, you've like socialized it to some extent. You need to actually write the draft. So a mailing list post is quite different from a specification draft. So like a mailing list post would be like, here's how I think it would work in like layman's terms, and the specification draft is like me sitting down and actually going through and writing up the technical, we'll do this, won't do that. I should have included some language from the spec. I guess maybe we can go look at it if we have time. So you need a specification draft. Once you have a draft, usually the person drafting it is also the person who's going to be implementing it. And usually drafts come from one of the teammates of the 3 or 4, there's like 4 implementations now of the Lightning spec. So then they will actually take their draft, they'll write the draft, and while you're writing the draft, you'll also be implementing it inside of your project, right? Remember, there's like 3 or 4 other Lightning projects. Okay. And then after you've done that, and you're kind of like gotten the specification draft to a good point, then it becomes your project to try and convince another of the implementation teams, 1, that your proposal is a good idea, and 2, that they want to take the time, energy, effort, and development hours to add that. Go ahead and take your specification draft that you wrote and take the time to read through it and implement it from the draft that you've written into their own code base, that new proposal for how Lightning should work, or like what changes they need to make, etc. Once that they've done that, then you need to check that these 2 almost independently written and coded implementations in the Lightning nodes work. So you can point them at each other and try and get them to do the stuff. When you point at each other, they should be able to complete the task, or whatever it is that you're specifying, actions that the nodes need to take when they talk to each other. At the end of it, if you're able to successfully have them point at each other and kind of like do the handshake or whatever it is that you're asking them to do or that you specified, once that's been successful, then and there's no other like comments or questions kind of from the rest of the loose lightnings committee, specification call committee that kind of ends up on the call, then the specification draft can be considered eligible for being merged into like the bolts officially as a new contribution as part of the spec. Cool. So you can imagine this is like kind of a bit of a long process. Great. So I want to talk through my experience getting a spec change added to Lightning. What I ended up getting added is something called dual funding. It also goes by another name, which is, what is it? Interactive transaction construction proposal protocol, also known as Open Channel V2. This is kind of the name of art I liked. It's got a bunch of different names for reasons. But yeah, so this proposal, like I kind of started like my journey in Lightning. I ended up joining the Blockstream team. I was the third team member on the Blockstream Lightning team. I joined in September of 2018. I think that's right. Yeah, I joined in September of 2018 as member number 3. Rusty used to joke that I was the diversity hire because I was the first Vim user on the team. Christian and Rusty both use Emacs. Cool. So I joined in September 2018, and then by November of 2018, I had my first mailing list post out about a proposal for advertising channel liquidity. Kind of like a problem that Lightning nodes have about how to get the ability to basically receive payments. Kind of complicated thing related to the payment channel stuff that I promised I would explain, but haven't yet. But anyways, so this is like my mailing list post. The thing about this proposal that I wanted to do is that in order to do it, it required another thing to happen first, and that's the dual funding thing. So that's this dual funding thing that I'm talking about. So my mailing list post was actually about something else, but in order to get here, I needed to add this new new like basically capabilities to a Lightning node where when they open a channel, kind of V1 channels, which is sort of the default on the network right now, whenever you open a channel, only one of the sides can put Bitcoin in the channel, which means that at the beginning of a channel, only the person who opens it can send payments out. The other person can only receive payments. My proposal, the dual funding, and the reason why it's called dual funding is that both sides, like so Lightning channels are basically a shared account between two people. We call those people Lightning nodes. And when they open up a channel, my proposal, my specification change would make it such that both parties to this channel would be able to contribute as much Bitcoin as they wanted at start. So whenever the channel opens, basically there's like kind of an opening process to a channel. It's kind of like going to the bank with like a friend and being like, we want to start a shared account. And then, you know, the money in it, we're going to like keep track separately what our balance is, but we're not going to tell the bank, whatever, kind of complicated. But the original version of Lightning channels, only one person of the two would be able to like put money in, and then the other person could just like initially receive money from them. My proposal lets both people who go to the bank put money in, and so they can both immediately start receiving money as well as sending it. So it kind of just makes them a little bit easier to use. And there's a reason you want to do that for other stuff. Anyway, so I started working on it. This is a draft. This is like the second time I attempted a protocol draft. I should probably go find. I kind of ran out of time on this presentation, but this was the second attempt. There was a first attempt that I think I pushed out in like 2020. And then a year later, I like basically rewrote the whole thing. And this was my second pull request. This is in the bolts repository, which is the specification side of it. So this is the actual written technical description of my protocol proposal on the bolts repo. It's 1,500 lines of code, and it garnered almost 500 comments over the lifetime of its stuff. And notice this is like, I don't know, I should probably hide this. This is like supposed to be a surprise at the end, but it did actually get merged in February of this year. So it's open for quite a long time. Yeah, so just got merged a few months ago, which is very exciting. This has been basically a project I've been working on since 2018, more or less, off and on. Less so. Okay, so kind of like what was the process of this? I feel like I did a bad job of getting these into like a way that I can really easily explain it, but basically it started with me like trying to make changes to the core Lightning code base to add all of this. I think I like wrote and then rewrote it like 2 or 3 times before it actually shipped in Core Lightning. This was my first attempt in 2019. It was like 4 different commits that I was trying to do. I don't know, it was like 4 chapters of commits. It was like thousands of lines of code in each one of these. And then my reviewer was basically like, no, this doesn't meet whatever requirements, go back and try again. So then I went and tried again. This was my second attempt, I believe. I attempted to get 8,000 lines of code in one pull request. It doesn't look like this one got merged. I don't know exactly what happened here, but this was in January of 2020. Right here, you can kind of see I've copied, like, this is what the actual, this is a wire diagram from the actual specification of how this thing is going to work. So anyways, it's a multi-year thing. Yeah, it's a monster. There's a reason I called it a monster. 8,000 lines of code is like not a thing you should do with a pull request. I don't know how many of you work on code, but this is like a egregious amount of code to have in a PR. There's a good reason that this did not get merged. And then finally, in like September 2020, I finally start getting things merged, like one piece at a time. So like this is just, you know, some preliminary work that needs to get done, more precursor work in order to actually get the thing that I wanted to get done. One thing that you run into when you're implementing new things from scratch is that there's like, I want to like actually achieve X, like I want to achieve X thing, but in order to get there, I have to like go all the way back to like this like little tool things. And you kind of have to like build all the little tools that you need inside your implementation until you can get to the point where you can actually get the work that you worked on. So it was almost like, it was maybe like 2 years of doing that in terms of like, just needing to do all this like little precursor work before I could actually get to the thing that I wanted to do. And then this is like the thing from the changelog in our implementation when I actually shipped it. I don't remember exactly which one this was. I think it was sometime in like 2020. So there's a flag where you could turn on my protocol if you wanted to. It's called experimental dual fund. And it would enable this new dual funded protocol I'd been working on for like 1.5 years at this point in one of our first releases. I think it got rewritten after this, but anyways, one kind of cool thing about Core Lightning is that we flag things behind this experimental flag until the actual proposal gets merged into specification and won't change. So I haven't like actually removed this from experimental yet in Core Lightning, but I can now because it's been merged. Okay, so I don't know if you guys are following along, but like this is like 2020, 2021. I have spent, you know, hours of my life implementing this proposal into Core Lightning. I've put out both the written technical specification proposal, which looks like that's this guy here. I like put this out into the world as of like 2021. And then I also have shipped it in Core Lightning and it's out there. And if you're running the Core Lightning implementation, you can turn it on. And if you're talking to another Core Lightning node, you can use my protocol now to open a channel, etc. Do I have like no, that's not the thing. This one. Oh, you guys can't see this. Anyways, there's like a Bitcoin magazine actually wrote up when we did the first mainnet Lightning channel ever. It opened on May 12th, 2021. So I'll just copy this from here so you guys can see this. This is kind of cool. This is kind of fun. So this is like I don't know, I'll put it here. So this is like, we had the first ever dual funded mainnet Lightning channel opened in May 2021, right? Okay. And then I started, and then what happened? And then I waited. So Core Lightning is out there and it's working. And if you're running Core Lightning, you can use my protocol. And we've already used Core Lightning to like open up one of these channels on mainnet. So it's like shipped. And like my part of this process, I wouldn't say is done, but it's like mostly done. But now I'm like waiting for one of those other implementations to decide this is the thing that they need to make happen and do that. And the team that ended up doing it was the SOMP team. They're like, hey, what you've got is great. It's going to help us get where we want to go with our project and our proposal, like how we think Lightning should work, etc. So then they took the specification draft and started implementing it on their end. They had changes that they wanted made that I had to then go back and add to mine. So here's one from February of this year where I'm like, there were updates that we made to the spec based on feedback from the async team. So I have to make changes. And then there's like the final. Are we done yet? I don't know. Are more changes coming? But eventually, as of eventually they got their shipped, they got it merged, we did interop testing, and then I finally got to hit the merge button this February for my protocol. So this kind of is like the biggest thing that I have contributed to Lightning in 4 years of working on it personally. And it's excited because it's merged. It's kind of funny because like the coda to this is like, this wasn't actually the thing that I originally proposed back in November of 2018. But now we've got like the basic groundwork for that done. I've got this proposal. I shipped this proposal for advertising channel liquidity years ago. Of course, it's like been implemented and works on Core Lightning, but we're finally at the point where Asank and I are now kind of like figuring out, and like the wider, Lightning spec community is also weighing in on this. Now that we've got like this preliminary of being able to fund channels with both sides, now we can add a new protocol on top of that that lets you pay someone to put money into a channel for you. So I could pay someone sats in a distributed, like kind of distributed marketplace way, where you could send me Bitcoin in the channel and I could put my Bitcoin into a channel for you. And that lets you receive payments over Lightning Network, which is cool. So we're finally getting around to maybe sometime this year, this original proposal will actually be specification, etc. So this is the open spec that I have on the Boltz network. Of like from 2021 of maybe we can add this liquidity ads proposal to Bitcoin. Maybe this will happen, or to Lightning. Maybe this will happen this year. Okay, I'm almost out of time. Hopefully that was interesting and entertaining. I want to do a short plug before I run out of time about the conference I'm running in Austin. I haven't really been super day-to-day active on Lightning. I've been doing more Bitcoin conferences because they're really important. I think everyone saw how maybe fundamental, I think, to scaling Bitcoin conference series was to getting scaling Bitcoin, like actually moving and coordinating people and getting together. So I run Bitcoin conferences now called Bitcoin Plus Plus. We're doing one in Austin, May 1st to 4th at the Palmer Event Center. It's going to be focused on kind of the next frontier of Bitcoin scaling or changes, which is how Bitcoin script works and changes we can make to change the script system in Bitcoin so that we can have more flexible and expressive contracts in Bitcoin, which will maybe let us do more fun and interesting things. Cool. Just a reminder, my name's niftynei. You can find me on GitHub, Twitter, Telegram, etc. at niftynei if you want to reach out. I think that's everything. I have a few resources and references, but I think that's it.
Thank you so much, Lisa. And yeah, so we'll have a few minutes to open up the floor for questions and comments. If you're able to stay maybe a couple minutes over our allotted time, that would be amazing. Yeah. Great.
I can do that.
Cool. So I know Venkat's got a question and Tim has got a question as well. If you have other questions, just raise your hand in the chat, or if you're on YouTube, go ahead and type it into the YouTube comments. Venkat, go ahead.
All right, yeah. So Lisa, one thing you didn't mention in your background, which I think people would find interesting, is you have experienced a wide range of environments, right? So now you live in Austin and you've kind of seen that scene. You were in New York, then you were in San Francisco. And on the more industrial front, you worked at Etsy, then you worked at Square for a while. So actually you've seen the trad payments world as well. And then you moved to Bitcoin, right? And another thing you didn't mention is that you do education stuff as well, the Base 58 course for training people to work on Bitcoin, right? Okay. So the question is, what are these sort of like engineering culture differences you've seen, I guess, both in industry and geography, as well as in a practical sense, when you do your teaching, what do you find you have to like, make people unlearn from, bad habits from, say, the startup world and learn in the protocol world? So complex question.
Yeah. No, I'm laughing because I feel like it's the biggest thing, and this might just be our implementation specific. I don't think that other implementations necessarily follow this, but for Core Lightning, where Rusty Russell, who is like, I would say across the ecosystem has the most experience working in open source, like for the longest amount of time. He's like our team lead. So he's like, has processes and procedures of like what is expected and correct. And I think the thing that one of the hardest things that was for me to learn, and that like the difference I think between working in industry on like a closed source project is what do you call it? The way that we use commit, like the commits that you make to a project, like there's like this whole, like you might write the code, but then there's a whole second project of like how you present the code and how you divide it up into a narrative around the change that you're making. And you do that through the commits that you make in the project, if that makes sense. So like that like big commit that I showed you that was like 8,000 lines of code, that was like not kosher. That was like not a thing that I was supposed to be doing, because my commits should have been like a story. Like I should be like, I'm changing this thing, and then I'm also changing this thing. Another really cool thing that I think that our implementation in particular like is really good at and cares a lot about, and again, this is because of Rusty and how Rusty's just like he's a legend. I don't know. Excuse me. But we do this really cool thing that every time that you our implementation is really, really closely tied to that spec document. So whenever we're coding or adding new code to, like when I'm implementing like a new like proposal, like I have to basically, there's like, when I'm implementing code, I'm supposed to be annotating it with the place in the specification that says I'm supposed to be doing this thing. So you're like, and then whenever part of our like build process basically goes and checks out the spec document and matches up those like basically like descriptions from the spec that you include with the code. And if the spec changes, basically like your build will break. So like if our implementation isn't following what the specification currently says, like you basically get a build error, which is cool. And that's like basically like, and that's custom, and that's like, we're the only implementation that does that. Core Lightning is also like supposed to be the most like implementation focused, like spec implementation focused project. If that makes sense. So we like spend a lot more time making sure that all of our stuff is like really heavily tied to what the spec actually says. The other projects are more focused on like being a startup, raising money, trying to get users, that sort of thing. So a lot of like the things that they prioritize and what they're working on are usually, and it's really interesting, like having like the politics of getting stuff done in open source and across all these different implementations is like a, let's call it a fun challenge. I think these things exist inside of like corporations and other projects, but when you have like, there's like literally 4 different implementations now. My spec is only implemented really in this like one other project now. So there's only 2 nodes, and of all the Lightning nodes on the network, it's maybe less than 10% of the nodes are like these 2 implementations. I mean, that might be growing. It's really hard to do statistics on what nodes are running on Lightning because of the privacy features that are kind of built into it. Anyways, sorry, I've talked a lot. There's a lot of differences, but it's fun. I think the one that makes me makes you a better coder in the long run is definitely like on Core Lightning, like you got to get your commits like nice little stories. Like otherwise it's.
Cool. You want to go again, Venkat, for Tim's question?
Oh, yeah, so Tim had to hop off, but yeah, he runs the parallel processing Ethereum. So he was on chat, like sharing like just how similar it all sounds. So that's kind of interesting. But his question was the point you made earlier about Bitcoin Core kind of not having a spec and therefore having a certain culture, and then Lightning having like a heavily spec thing, so a different culture. Can you speak a little bit to the cultural differences, I guess, between core dev culture and Lightning culture?
Not super well, because like I honestly haven't really spent much time trying to get stuff into core. I do have a PR out, and then like I haven't been working on it, and like, are you still working on this? Because we're gonna close it if not. I think the difference is that one thing that I've seen is that, so I think another thing that's really important to remember is that like as a project and as like a protocol, Lightning is like the Lightning protocol happens on like a peer-to-peer manner. So if you have 2 nodes that can talk to each other, but they're not talking spec, does anyone care? No, not really. Whereas in Bitcoin, consensus is very important, and every node needs to be like understand and talk the same language. And if you get one that is doing something like even slightly differently, all of a sudden you like start having problems. Like the whole network can fall apart. You get forks, and it's like terrible. So to some extent, the fact that like Bitcoin Core is like kind of a monolith, and there's one, and if you want to work on Core, it's like difficult, and it's a much it's a much smaller number of people that understand how that project works. It is I think it's got a lot more eyes on it. The politics are all over one particular code base. There are like separate implementations, like the L&D, like the Go team have their own implementation of Bitcoin called BTCD, which they originally, when they like launched their Lightning nodes, they were like recommending people run their version of Bitcoin D. I think most people just run Core though. There have been like a few bugs between the implementation. Like that's not generally what people do, if that makes sense, to run a different Core thing. But yeah, I think that what you end up seeing is that like the contention, like where does the contention happen? The contention in Bitcoin Core happens in pull requests, and it happens around like who's allowed to commit code. You know, are there forks of Bitcoin Core? So people will fork Bitcoin Core rather than like writing a new implementation. So like when there's any kind of like conflict, people will fork it and like add patches, or there'll be patches that float around for that one particular project. Whereas in Lightning, conflict tends to happen at the level of the specification. Which means that, you know, you can do what you want in your own protocol, and people will like add new implementation things that they want in the different nodes. The nodes all have different features and things that they do, kind of depending on what that team wanted to add, etc. And so the contention really more like gets focused at like, what does the specification say? Like, are we to spec? That kind of thing.
Awesome, thank you. Dorian, you have a question?
Yeah, I'm interested in the, so if it's 6 years from proposal to merge, if I understand correctly, what is that? How does that compare to other people's experiences? Like, you know, who is the fastest person who got a merge in, like, after the proposal? What was the content of it? Like, the extent, yeah, I'm not on the best audio, but just what was, that's basically the question, is that what's the comparison?
Yeah, I think it really depends on how important is it? Is it like a security critical thing? Like security critical stuff happens fast, right? Is it something that like, you know, and I think that like at the very beginning, like for that V1 of like what the spec was, like those 3 teams were all working together pretty quickly to try and get like the minimum viable Lightning product shipped. I think that was like a pretty quick process, like changes, etc. And everyone was kind of like on the same cart, pulling in the same direction. And once it got launched, all of a sudden you kind of end up in like this interesting point of like, okay, what's next? What is the next important thing, etc. My protocol, I would say, is probably on a complexity level fairly high. I would rate it an 8 out of 10 in terms of complexity and changes that are required to a node. And so the fact that it took a couple years, etc., and like there've been like people who are like, we don't want to do that. That's a lot of work, and introduces like new vectors of whatever. It's good for privacy. Like basically what one way of describing like the dual funding protocol is that it is it's like basically a decentralized coin join, like coordinator free way of building collaborative transactions. So like if the Lightning Network were to adopt it across the board, basically it would like increase the privacy on chain of Lightning transactions by like a huge amount, because you basically get rid of like a certain heuristics people use for on-chain tracking kind of stuff. So it's like quite a powerful protocol, but that means it's like quite complicated and has some like a little bit, so there's some edges to it. It's more likely, so that protocol that I wrote, one of the reasons that it got really driven through is that there's a follow-on thing that I guess my basically like I brought in a new contributor to Lightning who basically like kind of took the torch and like has been taking all the work I did with the dual funding and bringing it to like and the next stage is something called splicing. And that's like, so basically there's like a highly desired protocol change that sort of follows on, built on the work that I've done, that my friend Dustin in one of the TBAS, like a Bastien, a guy from the French project, are kind of like spearheading. And that's a really important project because it keeps up this like cool coin join stuff, which is really cool, but it also allows people to basically high level do liquidity reallocation for much cheaper across channels. So it basically makes cost of moving capital, like cuts it down a whole lot, which is cool.
Cool, thank you. Venkat, one more?
Yeah, so this just occurred to me. So in terms of like mutual influence between Ethereum and Bitcoin, like one thing I've seen on the Ethereum side is the ossification debate in Bitcoin was very influential in shaping the one on Ethereum, where the community was like, we should not ossify like Bitcoin. And going the other way, I've noticed that the NFTs to ordinals kind of like influence thing has sparked a little bit of like a culture war within Bitcoin of like we should not be doing Ethereum like NFT-ish things, whereas other groups say we should. So can you comment on that mutual influence thing?
Yeah, I mean, so from the mutual influence side, I know that like Joseph Poon, who's one of the original authors of the Lightning paper, kind of came from what I would say was sort of a thing that like I'm gonna get totally kicked out of the club by the Maxis for saying this, but he like, so the original Lightning like payment channel stuff, like the thing that made the Lightning Network proposal that Joseph Poon and Taj Dryja came up with, particularly like what made it better than all the previous proposals, because it kind of showed the list of like there were all these people trying to make payment channels work and they had different proposals, and it wasn't until this one came out that everyone's like, okay, yeah, that's the one. And the thing about it is that they took an idea that I think was percolating over in the Ethereum side, this like concept that I feel like Vitalik was the first one to really like this code is law. I don't know if you remember this. Like there was like an era in Ethereum where like code is law was like the new hotness, and like contracts, so like legal documents, etc. And I believe this was like 2015, right? This is when Lightning got proposed, or 2014, 2015. And the thing like that is the insight, like the contract law thing and judgment and judges, etc. Like that sort of ideation is like at the core of the Lightning protocol, of what actually got implemented. So like I think there definitely, there is a little bit of bleed, at least there was with that particular proposal. So Lightning in that way is kind of an interesting, like, yeah, like there was this like sort of mind share of how to do code as law, etc. Kind of thing. Which actually ended up in Lightning paper and then became like the Lightning Network is like the, the chosen one because of that thing, so to speak. I think like with all the recent NFT stuff, I mean, like the addition of like the inscription protocol to Bitcoin is definitely reactionary to the NFT like project. Like I know the guy who did the thing is like a friend, and he's actually the inspiration for my proposal for Lightning. Like the liquidity ad stuff came from a conversation from him, which is kind of fun. But like years later, he did this inscriptions thing, and he was like, the way that they're doing it on Ethereum is dumb. We're gonna do better. We can do better because we're Bitcoin. If that makes sense. So it's like, no, we're gonna like fix it. Like they're doing it wrong. They're doing it retarded because they're Ethereans and they don't know anything. So we're gonna fix it. We're Bitcoiners. We're gonna do it right, and we're just like write it into the blockchain forever. And of course, like now there's this whole internal cultural war about filtering, and like that brings up all sorts of like fun things in Bitcoin about censorship, etc. But yeah, I think there's always been kind of this like, it's one of those things where you see interesting things happen, I think, when ideas get shared across ecosystems. So yeah.
Awesome. Well, I think we're about 15 minutes over time. So thank you so much for spending some time with us today and talking about your project on the Lightning Network. And yeah, we will see all of you next Wednesday for a talk with Josh Stark on hardness. Thanks, everyone.
Thanks, Lisa.